My name is Josh Wendell, and this is chapter 3.3, number 8. You start with the equation 6x squared plus 2x cubed times y double prime plus 21xy prime plus 9 times the quantity x squared minus 1 times y equals 0. What you want to start to do is divide everything out by 6x squared plus 2x cubed, right here, 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 and here. And to get this form right here, so you get y double prime plus 21 over 6x plus 2x squared y prime plus 9 times the quantity x squared minus 1 divided by 6x squared plus 2x cubed all times y equals 0. And that gets you the equation in the form that you want right here. And so the equation form you want is y double prime plus px y prime plus qx y equals 0. Using those values, your px here and your qx here, your px is 21 over 6x plus 2x squared, and your q of x is 9 times quantity x squared minus 1 divided by 6x squared plus 2x cubed. And then from there you want to take limits of your p of x and q of x as x approaches 0. So by doing this, we're taking the limit of p of x as x approaches 0, which is the limit of 21 over 6x plus 2x cubed. You can see I replaced the x's with zeros because that's where x is approaching. That limit doesn't exist. So we move on to take the limit of q of x as x approaches 0, which is the limit of 9 times the quantity x squared minus 1 divided by 6x squared plus 2x cubed. Once again, I replaced the x's with zeros, and we're dividing by 0 just like in p of x, so that limit doesn't exist either. So that says it's x equals 0 is a singular point. And then from there we move to take the limit of p naught and q naught as x approaches 0. And by doing that, p naught is just x times px. So you take the limit as x approaches 0, and you multiply your p of x times x, which right here, which gives you 21 over 6 plus 2x, and then it goes to 21 over 6, which ends up being 7 over 2. So that's your p naught. And then you do the same thing for your q naught, except q naught is x squared times q of x. So when you take that limit, you're taking the limit as x approaches 0 of x squared times q of x, and that equals, after multiplying everything by x squared, that equals 9 times quantity x squared minus 1 times x squared divided by 6x squared plus 2x cubed, and then that equals the limit as x approaches 0 of 9 times the quantity x squared minus 1 divided by 2x plus 6. And then we can see that you replace your x's with the zeros, and you'll get a limit of negative 3 halves. So our p naught is 7 halves and our q naught is negative 3 halves. That says that x equals 0 is a regular singular point, so then we can find values for r, or our exponents. And then using the equation that we're going to want to use is r times r minus 1 plus p naught r plus q naught equals 0. And we already solved for our p naught and our q naught, so it's a pretty simple equation right here. So r times r minus 1 plus 7 halves r, which was our p naught, minus 3 halves, which was our q naught, equals 0. Multiply both sides of the equation by 2 to simplify it. So 2r times the quantity r minus 1 plus 7r minus 3 equals 0. Then once you factor that out, you get x plus 3 times 2x minus 1. And you can see that our r values are going to be r1 will be negative 3, and r2 will be 1/2. So the exponents of the differential equation are negative 3 and negative 1/2. Or excuse me, negative 3 and positive 1/2.